Good morning to everyone. Welcome to the course Linear Algebra and Calculus. Myself Sujatha, working as Assistant Professor in MLR Institute of Technology, Hyderabad. Today I am going to discuss Jacobian. So first I will explain what are the applications of the Jacobian. We can apply Jacobians in transformation or in change of variables, and it is also used in change of variables and machine learning. So the overview of this presentation is definition of the Jacobian, properties of the Jacobians, and some problems related to the Jacobian. So here the definition of the Jacobian is if u, v, w are functions of x, y and z, then Jacobian of u, v, w with respect to x, y, z is denoted by this form: dou u, v, w by dou x, y, z equal to determinant of dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, and dou w by dou x, dou w by dou y, and dou w by dou z. So similarly you can write Jacobian of u comma v with respect to x comma y is denoted by dou u comma v by dou x comma y. So this is equal to determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So the properties of Jacobian is chain rule for Jacobian. If u and v are functions of independent variables r and s, and r and s are functions of x comma y, u and v are functions of r comma s, and r comma s is again a function of x comma y. If you want to find out Jacobian of u, v with respect to x comma y, we can apply the chain rule. So this is dou u, v by dou x comma y is dou u, v by dou r comma s into dou r comma s by dou x comma y. So if u and v are from second property is if u and v are functions of x comma y and x and y can be solved in terms of u and v, Jacobian of u, v with respect to x and y and Jacobian of x comma y with respect to u comma v is 1. So if u, v, w are functions of x, y, z, if u and v, w are functionally related or functionally dependent, Jacobian is 0. If Jacobian is 0, dou u, v, w by dou x, y, z, Jacobian is 0. We can say that those u, v, w are functionally dependent. Functionally dependent means there is a functional relation between u, v and w. Suppose if Jacobian dou u, v, w by dou x, y, z not equal to 0, we can say that these are functionally independent. So we can see the problem related to the Jacobian. So if u is x square minus 2y, v is x plus y plus z, and w equal to x minus 2y plus 3z. So we can see how to find out Jacobian of u, v, w with respect to x, y, z. First, if you want to calculate u, v, w with respect to x, y, z, u, v, w must be function of x, y, z. We have to check that one. U is function of x, y and v is function of x, y, z, w is function of x, y, z. So we can directly calculate Jacobian. So dou u by dou x equal to, with respect to x, derivative of x square is 2x, derivative of 2y constant 0. So dou u by dou y, dou u by dou y with respect to y, x is constant, derivative of x square is 0 and derivative of 2y is minus 2, and derivative dou u by dou z with respect to z, there is no z term, that's why derivative is 0. Next, dou v by dou x equal to, with respect to x 1, Dou v by dou y with respect to y, that is also 1. Dou v by dou z with respect to z, derivative of z is 1, that is 1. Next one, dou w by dou x. Dou w by dou x. Dou w by dou x is derivative of this one with respect to x is 1. Dou w by dou y. So this value is minus 2. Dou w by dou z. This value equal to 3. So first we have to find out the partial derivatives. So the definition of Jacobian is dou u v w by dou x y z equal to determinant dou u by dou x, dou u by dou y, dou u by dou z. Dou v by dou x, dou v by dou y, dou v by dou z. Dou w by dou x, dou w by dou y, dou w by dou z. So calculate the determinant. Already we calculated dou u by dou x and all the values. Dou u by dou x value is 2x. Dou u by dou y value is minus 2. Dou u by dou z value is 0. Dou v by dou x, dou v by dou y, dou v by dou z, all the values are 1. Dou w by dou x is 1. Dou w by dou y is minus 2. Dou w by dou z is 3. So expand this determinant, we will get 2x into, so determinant of this one 2 by 2 matrix, 1 into 3 minus 1 into minus 2. So 3 plus 2. 3 plus 2 is 5. Minus plus 2 into, so determinant of this one is 3 minus 1. So plus 0 into determinant of anything is 0. So we are getting this is 2x into 5 plus 2 into 2, 4. So this is 10x plus 4. So the Jacobian value is 10x plus 4. Next we will see one more problem. So if x plus y plus z equal to u, y plus z equal to uv, z equal to uvw, then evaluate dou xyz by dou uvw. First, if you want to calculate dou xyz by dou uvw, x, y, z must be function of uvw. First, we check it x, y, z are in terms of uvw or not. So here x, y, z are not functions of uvw. That's why first we have to convert x, y and z must be function of uvw. So x equal to, from the first equation x plus y plus z equal to u. From that y x equal to u minus of x plus u minus of y plus z. So but they are given y plus z equal to uv. That's why we can write. So this value is u minus uv. Therefore x equal to u minus uv. And next one is y plus z equal to uv. From this y equal to uv minus z. Already we know z is uvw. That's why y equal to uv minus uvw. Next z equal to function of uvw. No problem. So x, y, z must be function of uvw. That's why calculate partial derivative of x, y and z with respect to uvw. So dou x by dou u, dou x by dou u. With respect to u, we have to keep v and w must be constant. Derivative of this one is 1 minus v. Next, dou x by dou v. Dou x by dou v equal to, so derivative u 0. Derivative of v is 1. Minus u into 1 is minus u. Dou x by, sorry, this is dou v. dou x by dou w. Dou x by dou w is with respect to w, there is no w term, that's why that value is 0. Next, dou y by dou u. So y is uv minus uvw. So with respect to y, we have to keep v and w must be constants. So this is v minus vw. Next, dou y by dou v. Dou y by dou v equal to u minus uw. Next, dou y by dou w. So this is minus uv. So dou z by dou u. Dou z by dou u is v into w. Dou z by dou v. So this is equal to u into w. Dou z by dou w, that equal to u into v. We are calculating the all partial derivatives. Next, we have to use the definition of Jacobian. So dou xyz by dou u v w. So the definition of the Jacobian is determinant of dou x by dou u, dou x by dou v, dou x by dou w, dou y by dou u, dou y by dou v, dou y by dou w, dou z by dou u, dou z by dou v, dou z by dou w. So we calculate all these partial derivatives, substitute all these values, we get dou x by dou u, 1 minus v, determinant of 1 minus v. Next one, minus u. Next one, 0. Next, dou y by dou u is v minus vw, v minus vw. Next one is u minus uw, u minus uw. Next one is minus uv. So next one is dou z by dou u is vw. Next, dou z by dou v is uw. Dou z by dou w is uv. So expand this determinant, we will get 1 minus v into, so determinant of this one, so u minus uw into uv. So this is equal to u square v minus u square vw. So u square v minus u square vw. So minus minus plus plus u square vw. Minus u, minus minus plus u into, we are getting so determinant of this one, v minus vw into uv. So this is equal to v square u minus u into v square w. So this is v square u minus u into v square w plus v square into uw. So minus u into v square w plus v square into uw, that is cancel. So minus u square vw plus u square vw, this is also cancel. We are getting 1 minus v into u square v plus u square v square. So this is equal to u square v minus u square v square plus here is u square v square. So this is cancel, we are getting u square v, u square v. So that is the answer for the this one, dou xyz by dou u by uw, that is u square v. Thank you.